So thanks everyone for joining. I'll go with a quick recap of what we had done in our last session. So I had started by showing how these models, whatever we call them, AI, generative AI, LLMs, how they basically choose the next word. And for that, I had given like a very basic example of what is called as a unigram, which essentially is the next word is predicted based on what was the previous word, right? So in this case, cat is the previous word. And we had seen in our data that, cat is followed by sat, cat is followed by drank, and cat is followed by whatever. And based on that, for every word cat, what is the probability of the next word? So in this case, let's consider this as our whole training data. Then the possibility of after the word cat appears, the probability of the next word is for only two words because that is how many times that is those are the only words that appear in the training data after cat and for the rest of them the probability is zero, and even out of those two sat has a higher probability because sat is coming more times after cat in the training data set. So that's the reason after cat sat is supposed to come. So if you see over here when I do predict next word, it will show that okay, sat is supposed to come and sat, and the same thing keeps happening after sat. What is the next best word, what is the next best word? So it keeps generating the next best words based on this logic. uh, One question that had come up during the last session, which Vaibhav had asked, was does ChatGPT also work on the same principle? And the answer that I had given was yes, it works on the same principle. So I have a very small demo to show like a real GPT model on how it works behind the scenes so that we can validate that, okay, whatever I was talking was not fluff. And that is how, that's the fundamental principle of any generative AI model. So I'll come to that a little later. But one more question that might crop up in, people's minds is, uh, in this case, if you see, every time I reset and I predict the next word will always be sat, which means if I just autoplay and let it, generate the words one after the other, it will always generate the same sentence again and again, again and again. Now, this makes sense because that is how the probability distributions are, right? That is how these words are. That is how our training data was. But when you actually go to, let's say, real chat GPT, right? And let's say you try out something like write a poem on wind. So it will write a poem. Now, if I take the same exact literal words and I again put it in a completely new window, let's see whether it generates the same poem or not. So in this one, it generated something like whispers of wind, whatever. And in the other one, it generated the wind now arrives without a name, whatever. The wind does not knock. So it generated different words. It generated two different poems the both times. Even though I gave the exact same words as inputs, and the model behind the scenes is also the same. I didn't change the model at any point in time, right? I didn't change any other parameter, but still the outputs generated are different. That essentially means that something is happening behind the scenes which is making this different. And that is what I want to show basically. And this will connect ultimately to the SAP module, the Gen AI hub that we are going to do as a hands-on in today's exercise. So yeah, so this is basically one thing that we need to remember, that even if you give the same input again and again, the model is not going to generate the same output again and again, right? You do this 100 times, it's going to give 100 different outputs, right? So if you see the wind arrives without a name over here, it says, I don't know if it gave the wind does not knock. Oh, it did give the same first sentence, but I'm sure that there would be some difference later, right? So this is one thing that we need to remember about these models, that they don't generate the same output even if you give the same input. Uh, Anyone here? has any idea or any thoughts about why that is happening? If you guys want to attempt, make a wild guess on why that would be the reason, what could be the reason behind that? You can take
Users
your own.
context,
I'm sorry.
users context.
What do you mean by users
So
context?
basically, if ChatGPT knows you as a user
Mm-hmm.
and it has context of talking to you over time,
Mm-hmm.
perhaps it could use that information to create an answer, which basically use it as spices to change the taste of the item.
So the answer is no, that is not what is happening, but it's a good attempt because we will come to memory later, which is essentially what these ChatGPT as a product is capable of. But if that's the case, in that case, my context would have been the same, right? So, but I had only tried the same input three times, but still it generated the same, it generated different outputs. So my context would have been same based on whatever it has learned about me based on all the chats that I've done. So ideally, in
Right.
that case, it should have generated the same output for me. Probably different people trying out could have generated different outputs, right? Uh, yeah, but users context is definitely not the reason. Users context is a reason for some other things, but not this specifically. Uh, what I'll do is I'll go next to what is actually the reason behind this, right? And we will slowly converge into something which binds it to the Gen AI Hub exercise that we are going to do next. What I'll do is I will run locally an LLM. So whatever I was running, the Chat GPT thing that I was running, right? That was running on Chat GPT server. I don't know where those servers are, where the model is hosted. I don't know. I'm just a user of this. But Chat GPT behind the scenes is supported by a GPT model. It's called a generative pre-trained model, right? Generative pre-trained model is a model that generates something. It is pre-trained on some data, and T is for transformers. So GPT is generative pre-trained transformer. Transformer is like an architecture. You can actually ignore it. It doesn't matter, right? What I'll do is I'll actually download a very small version of a GPT, which is the first GPT model, you could say, that OpenAI had actually open sourced. And this was long back, like 2019 or something, if I remember correctly. So they had open sourced this for people to use it on their own systems, right? So I've downloaded one model locally, and uh, I will show you how exactly it predicts the next word. The demo that I had shown over here, right, was completely made by myself. I had literally given it only these number of sentences as the training data. But over here, that's not the case. Over here, the training data is something that the OpenAI people, the team of OpenAI had created themselves. And they had actually, trained this GPT-2 model and they had pushed it somewhere. I just downloaded it from there and I'm running it locally to show you how the next word prediction happens. Over there, in the last session, I had told that there is something called as vocabulary, which is all the words that our model knows. In this demo case, all the words that the model knew were basically these: the cat sat on a drank dog. So these are four, five, six, seven words. This is the vocabulary. These are the only seven words that this model knew because that was the only training data that I had given, right? So that was the only training data that I had given. Now, what about this particular model, the GPT-2 model? The GPT-2 model has 50,257 unique words, actually tokens, but I'll not go to that detail right now. Just assume words that it can predict. So whenever you give it some input, it can choose out of 50,257 different words as the next word, right? And just to see what are these 50,000 words, right? I'll just show you what its vocabulary is. So its vocabulary, if I just go and see the first, let's say 10 words, right? The first 10 words will look something like this. Mm, yeah. So the first 10 words are just some special characters, right? I'll let's say see from 100, or sorry, 1000 through 1020th word, right? Mm. So as you can see, it is some tokens. As I told you, so there is this word called if, there is this word called trans, Trans, there is this word called take. So these are all the words. And then if you just go to the last 25 words, then these are all the words which come at the end. Skip, rappels, and then there is something called as end of text, which is that's the end. This is the last token, right? This is also actually a token that it predicts. Now, what I'll do over here is I'll just give it some random sentence and I will see what happens to this sentence, right? So this is the input sentence that I want to test with. This input sentence is actually broken down into smaller pieces, and that list of small pieces called as list of tokens, right? That basically goes as the input to the model. Now, if you see, this is the model that I had downloaded and loaded. This is where I had loaded the model. If you see, the variable is called model. And when I actually call this model with the input IDs. So there are these tokens, which are English words that a human can read, but these words need to be converted into numbers because numbers are the only things that machines understand. So these tokens are converted into those numbers, and those numbers are given as an input to the out model, and the model gives an output. We all understand that when you give an input to a model, it gives you some outputs. And of course, the machine can also generate only numbers. So the machine also only generates numbers, which are called as logits. I'll come to what that are later, but I'll run this cell first. What it has done is it has given me the input token shape was 1 comma 5, which is these 5 words. So 5 words I have given as an input, and the output that I got, if you can see, is a 50257 length vector. So logits for the next token are of the size 50257. Now you might say, what is this 50257? If you remember, when I was answering Vaibhav's question the last time, I had told that for every next token that the model predicts, it actually predicts a very, very long vector. The size of that vector is the length of our vocabulary. And in that vector, it is essentially giving us the probability for the next token to be the actual next token, right? So what it has given us is a very long list of numbers. For every token or for every word in our vocabulary, it has given us a probability. Actually, in this case, it has not given a probability. It is something, it is called as logits, and then we do some operation on top of it, which actually converts it into probabilities, right? So if you see, the sum of all the probabilities is 1. Just ignore this 1 2, this is a Python problem, and then some minimum probability, maximum probability that it has given. And if you see, the top 10 next predictions for the input capital of France is the the best next prediction can be actually the, in according to GPT-2, right? It could be wrong also, 0.0846. If you see France, the capital of France is France, has more probability than the capital of France is Paris, which is strange, but that is how language models work. And this is GPT-2. This was very old model, right? Now, this is exactly what it is. I only took the top 10. Actually, I got a list of 50,257 probabilities. I took the top 10 probabilities, and if I choose the one which has the maximum probability, that will essentially be my next token. This is how GPT works. This is exactly what we did over here as well in the demo, right? So I just wanted to set that context that whatever GPT is doing is actually this. It is just predicting the probability of the next word and just generating answers which people feel magical, right? That's basically about it. Now, there are a bunch of things that come in handy when you understand these things, and all of these things will be useful later on when we are actually doing the exercise that we are planning to do. I'll just take a pause over here. If any one of you has any questions or anything, we'll take those questions for 3 minutes, and at 4:20 we will start the session for the whole, SAP thing. Yeah, yeah. Go ahead, Vaibhav.
So, you said like the maximum number, like it took as like 50 to 7 some number, right? Like, isn't it the whole data set like it would every time take, because that's the whole data set that will have like those are the total number of the tokens.
Yes. So, uh, GPT-2 was trained on a lot of web data, which essentially means some web crawling happened. It scraped a lot of data from the web. Now, this 50,000, whatever number that we had, right? This 50,000 is the unique, it is all the unique words out of that data. So there must have been Harry Potter books, there must have been, the script of 300, there must have been a lot of data on the web. When you take all those words, all of those words, stories, books, whatever there are, and then you take every unique word out of it. So one word becomes one value. There are 50,257 tokens to predict. If you take all the training data and you just say ki this is the maximum number of words that are possible in English language. Think of it as Oxford Dictionary. So Oxford Dictionary, if you consider that Oxford Dictionary has all the words that are possible in English language, and the number of words is, let's say, 50,257, then when I'm speaking right now and I only know words from Oxford Dictionary, then the next word that I'm talking right now literally can only be present in the Oxford Dictionary, which is this 50,257. And the model has to only predict one of these 50,257 words as the next word to keep continuing. Like, I am speaking right now. If you see this, all of these words are actually present in Oxford Dictionary. And I know because I have read a lot. I don't know the whole Oxford Dictionary, but I have read a lot of books or I have read a lot of blogs where these are used. So I know how to predict the next word. My brain knows how to do that. That is exactly what this model is doing.
Yeah, right. So that means like you have taken like the top 10 like most likely ones, like although within the
Yes,
probability. So it's always that like it will take within the first 10 or whatever you try to prompt or put the logic as, right?
yes. Now, this is what we will see in the what we call in the session, this SAP Gen AI module, the session that we have, right?
Okay,
So
okay.
that is essentially what we will see. But since you have teased it, right, I will just show you something called as temperature, top K, and top P, right? These are some parameters that you can essentially set in your model, which essentially decide fan. नहीं, fan. So these are essentially some parameters that you can set in your model, which will decide what will be the next word. And like I did, right? I did a top 10 over here. Top K is literally that value. This top K sampling, if you see, top K keeps only the K highest probability tokens and zeros out everything else. So what the question that you asked, Vaibhav, is essentially what is the top K that ChatGPT has? I don't know that because we never get to set it. But if you ran a local model yourself in any project that you have, then you are the one who decides what is the top K that I you will need to take based on whatever use case you have. In a similar way, there are other things like top P. There is something called as temperature, which we will actually see in the module that we are going to see. Yeah.
Okay. Yes.
Does that
Thank
answer
you.
your question?
Yeah, yeah.
Cool, cool. Anything else? Anyone wants to ask any doubts over here?
And one question, Shiva. See, GPT, the next word prediction, right?
Hmm.
And if the context is something sequential data, right, or English based data. So how what I think like how the code generation happens like because in a coding there's a no sequential data happens, right? But it's still
No.
it generates the data.
Yeah.
In poems,
Code.
yeah, there'll be the chances like it's a English based something, so it can easily generate it.
Hmm. Anything that happens one after the other in this world, right? Anything that happens one after the other, which is almost everything in the world, right? Because there is a
Mhm.
time dimension for everything that happens in the world. I am speaking, I can't speak everything in 1 microsecond. I have to speak over time. So I am generating sounds over time. When I'm drawing something, I can't draw everything at once. I need to start, put my pencil, draw, and continuously draw over time. When code is also written, you don't write all the code at once. You write code, you literally type the words of the code, right? So anything that happens over time essentially means that you are predicting the next step while you are writing the current step. So when I'm writing my name, I know my brain already knows that the next word is Shiva. So the whole world actually works on predicting the next moment's happenings, right? That is essentially what GPTs do. If you give a lot of historical data of what has happened over time, it can predict what can happen in the future. That is essentially what it is. Whether it will be a very good prediction or a bad prediction is something that I can't tell, but it will do some prediction. And that is what is used everywhere in text generation, in audio generation, in video generation. Everywhere you have time bound data, which essentially means the data is completely dependent on generating a lot of things over a period of time. And that is the reason why, after someone cracked that, okay, I am these models are very good at generating text. They were like, what are all the other things which are based on time? And they just started putting that data into this model and started generating new things. That's how image generation happens. Because if you think about image generation is like generating a lot of pixels one after the other, which
Right.
is how we also draw. Code generation is also like that. Music generation is also like that. So anything that is done over a period of time can be done using GPT. How well it can be done is questionable, but it can be done. Yeah,
Yeah, got it.
cool. So now I'll move on to this module which I was, referring to on the group. I'm hoping that all of you were able to log into this. This is a decent enough module for someone to start and is enterprise level also. So the reason I wanted to take something enterprise level was because whatever I speak should make some sense for them in the work that they do in their day-to-day lives. And SAP is a huge organization and a huge this thing which has been in the forefront of AI also since quite some time. And they have this, Gen AI hub, which is essentially one place where you can go and build some generative AI kind of applications of your own, not use tools like ChatGPT to, generate poems or stuff like that. You can actually build something of your own over here. I won't take you through this. Okay, I got logged out. Let me just log in a minute. So I won't take you through this, whatever it is, right? Uh, just one thing that I'll note is that we will be covering these points in this session. If not today, we'll continue the session tomorrow as well. But we'll basically be covering these things. You don't need to know all of them right now, but just wanted to point this out. I'll quickly go to the next one. Uh, Again, this is some SAP bullshit I don't want to cover. Uh, so this is a good starting point. Uh, Lesson check. So if you see, I'll go to this AI Launchpad thing that they have, right? And I'll choose what are they asking us to choose? Choose the doc grounding resource group. So this is enabled, so I can choose that. And over here, if I go to chat, then I can start the module that we are essentially trying to start. Hmm. So we have started something called as chat. This is essentially like chat GPT. So if I say hi, it will say hi, right? So Sridhi, Sridhi, record. If I say hi, it will say hi, right? Now, This is essentially like the way ChatGPT works. But why would I want to bring you to another ChatGPT when you already know about ChatGPT? The reason is because this is something that I wanted to show you on how it works on, you know, enterprise platforms and what are the things that you have in your hand to control your outputs. We had already seen temperature in this over here, right? I'll just give you a very brief definition of what temperature is from an effect point of view, right? What are the effects of doing changing temperature? What is literally happening behind the scenes? I will not really go. I can do that also. There are some things over here, but I'll just tell you what are the effects of changing a temperature. It is said that, mark my words, it is said that if you keep a very low temperature, which is a zero value, then the model is not very creative in generating its answers. If you set a very high temperature, which is 1, 1.5, 2, whatever you want to set, the max is 2 usually. If you set a very high value, then the model is very creative in answering your questions. The reason behind that is actually when you are predicting the next tokens. Like you saw over here, we took the top 10. But out of these top 10 also, do you always want to choose the first one which has the highest probability, or you want to be creative? If you are setting a temperature of 0, then it will always select the one which has, let's say, the highest probability. Whereas if you set a temperature which is higher, right, which is, let's say, 1 or 1.2 or something like that, what it does is it changes this distribution. If you see, for a temperature 0, the distribution remains the same. So the first word which has the highest probability is over here, and the rest of the words are over here. Whereas when you change the temperature to a very high value, you can see that all of these distributions have, just, uh, reduced to a very low value, right? So the distribution becomes very stable and it becomes very uniform. So the next word choice becomes more random compared to what it would have been if the temperature was 0. And that's the reason people just say that it is more creative when the temperature is high compared to the creativity when the temperature is low. I'll actually take one very basic example also over here to show that. Yeah. So if you run this right, yeah. So when you see the temperature, when I set it to 1, yeah, when I set the temperature to a very low value, low temperature, it just generated. So the input was this. In the future, artificial intelligence will be able to do things that human can't. This is with a very low temperature, a good enough value, good enough output. But when I change the temperature to 1, which is a decently high value, it generated a lot of text, which essentially means that it is just able to do better choice of words or more creative choice of words. I wouldn't say creative because I know that it's not literally creative, it is just random. But that randomness is bringing in the creativity. And that's how many random people are also very creative in general. And the same thing happens when you do even higher temperatures, right? It goes even berserk, it goes crazy, and it generates some random things. If you see, in the future, artificial intelligence will grapple situations that Hampe carries Roos beat frequently. Sorry, April being with Pawn. Okay, I don't know why it gave Pawn, but yeah. The point is, it just was very random, and that is what temperature does to you. Now, that actually brings us to a thing like what should be the temperature when you are actually building your own AI systems or whatever, right? If you want it to behave a little properly and if you want it to follow your instructions, then set a very low temperature. If you are into a business where you are generating scripts or if you are generating something like a poem or whatever, I don't know if that makes any sense in an enterprise setting, you would want to set a very high temperature. In this case, they have given a value of only till 1, but if you work with other models, you will see that they go up to 2 also. Another thing is called as max tokens. Max tokens is like what is the maximum number of words that you want to generate in an output. For example, over here they have set it to 64,000, which is a limit. So whenever you give one input, in this case, when I said hi, the maximum limit that it could have generated was only 64,000 tokens. Assume 64,000 words, right? But it didn't. It stopped in between because one of the tokens that it can predict is end of text, which we saw in this particular thing, that one of the tokens was end of text tokens, right? In the vocabulary. So whenever it predicts end of text as the token, it stops generating the output, right? But it if if I ask something, right, if I ask it to write a story as good as Harry Potter, then it will go till that 64,000 token and then it will stop, right? Now you can actually set it to a very low value. I'll set it to 1, let's say, right? And I'll see what it does. It didn't generate anything. Let me set it to a little higher value. Yeah, let me set it to 5. Now I will do quiet. Now you might say, ki, okay, these are only 2 words, but actually, as I have been saying, it doesn't generate 5 words, it generates 5 tokens. Now, if you see, it generated it in bold, it generated it in, a large font. So all of these comprise of 5 tokens actually. Now, you might have use cases where you want to limit this for many reasons. That's the reason they are giving it as a parameter, because you don't want the model to unnecessarily generate output tokens because they cost. So if you know that your use case will always generate only 5 words as an output for whatever reason it is, right? Let's say you are only doing a email classification problem, like in Gmail, you classify an email into spam or not spam. You know that the prediction that you want to do is either the word spam or not spam. So why do you want to generate 1,000 tokens for that, right? You can only generate 5 tokens probably, because the only prediction that you are planning to do is spam or not spam. It costs a lot for output tokens. That's why you should control what output tokens how many output tokens you let the model generate. If you just give it a very high value, if it wants, it will generate a lot of output tokens. You don't know how these models would behave at any point in time, right? So that's the reason you should always keep that. You can set this thing in your application. And the most important thing, the one that we saw last time also, on how do you choose your model. We had done a very good example of, you know, two animals, combining the two animals and, getting the names of the two animals from the combined word. So that exercise, we saw that a very good model, even without a lot of context, is able to solve the problem. Whereas for a very small and a naive model, like let's say haiku or something, we had to write a very detailed prompt for it to solve the problem, right? So that is the trade-off that we have. And you have something called as a model garden. This is usually called as model garden. Model garden is basically a garden from where you can select a model, literally that. Within the model garden, usually people tell what are the models that are available and who are the providers of those models. This is usually important in enterprises because not every enterprise entertains models from every provider. For example, you trust Amazon, so you might want to only use the models which are actually trained and hosted by Amazon. Your company might be a little fine with Anthropic, probably, right? And that's the reason. We had a client who was completely on GCP, which is Google's cloud computing, right? So over there, you would always want to use Google's models, the models that Google trains and Google hosts, right? So these are the places where you can, pick and choose. Uh, there is something called as leaderboard. Leaderboard is basically a place where you can know which is the best model for certain tasks. Like one model could be very good at generating code, another model could be very good at generating music or whatever, right? I'm just making this up, but yeah. Usually, every model garden has a leaderboard also for the user to clearly understand how to choose a particular model. That's the 3 parameters that you can set from a model point of view. The reason these are called model settings is because they literally impact the model. They are not peripheral to the model. They are actually going and sitting somewhere inside the model to generate the output. That's why these are called model settings. Then there is something called as chat settings also. What this essentially means is this comes outside the model, which means if you see something called as context history. Now, context history is nothing but I am actually, okay, what I'll do is I'll probably start a new chat. Clear, right? I'll go here, I'll set a context history of only two messages, right? And I'll do a apply. I'll start by saying is Shiva. Nice to meet you. What is your name? I'm Claude. Okay. Also, just remember that I had set 5 or something as the max token or something. I don't remember, but anyways, I'll continue. I'll say I like, that's great, basketball, whatever. What do you like? I appreciate the question. So it is generating some garbage because of all the settings that I did in the previous one. But now if I go back and ask it, what is my name? I don't know your name. It says I don't know your name, even though I told it that my name is Shiva. The reason for this is I had set a chat context of only two messages, which means when it is answering some question that I'm asking, it will only refer to two messages from the historical chat. It will not refer to any more messages than that. And if you see, this is like the fourth or the fifth last message that I had put in, right? So it becomes very important when you are building AI or generative AI kind of applications. What is the chat context that you set in your application? Because in some applications, it might not really matter what is the context that you give it, right? How much of historical data that you give it to generate its answers. Whereas in some cases, it matters. You want to make sure that, even like very, very old messages it can refer to when it is trying to, answer your questions. So that is why this setting becomes, very important. I'll just increase this, apply. I'll clear history, clear. I'll start again. Okay. Now, if I ask your name is Shiva, because I increase the chat context, which essentially means I'm letting it see more of the historical messages. Now, you would ask, how is this happening? Actually, what these chat applications, this is a chat application if you think about it, right? What these chat applications literally do is they take all of these messages like this. They copy this, they copy this, they copy this, they copy this, and they give all of this as a context and then add it to the question that I'm asking and then call the model, which is literally what was happening over here. So, if you see this in the future, artificial intelligence will, right? So, it answered something. Now, if I add all of this was, let's say, my first message, and this was the answer. So what in the next message that it goes, right? It will do this. And now if I again run this, right? In the future, artificial intelligence will be able to do things that humans can't. It will be able to do things that humans can't do. It just generated gibberish because it's a GPT-2 very, very old model. But you can see what it did. The chat applications literally take whatever you spoke and it just generates longer prompts and it keeps generating the answers. So it's not doing anything magical over here, to be very honest, right? When you're setting the context, what it does is Whenever you ask a new question, it just takes the last, if you set a context window of two messages, it will just take last two messages that it had that we had in our chat, and it will just append that, or you could say prepend that into the prompt that you have asked, and call the model and generate an answer. So that is essentially what this chat context means. Then there are few other things like user prompt, assistant prompt, and system prompt. User prompt is nothing but whatever question the user is asking. Assistant prompt is, it's little counterintuitive in the way that uh, whatever the assistant is generating. In this case, assistant is chat model, the haiku model that we have chosen. That is the assistant for us over here. Whatever it is generating. So uh, you don't really need to worry a lot about assistant prompt. You can ignore that. But then there is something called as a system prompt. System prompt is usually the role that you would want to give the model. A system prompt essentially defines, these are segregations that humans we have done for the model, right? The model doesn't really know that this is a system prompt, this is a user prompt or whatever. The model just understands a bunch of text. For us to, clearly write prompts and clearly define prompts, we have created these segregations. So what usually people do, or what engineers say, is that if you have something that the model should always follow, then you should include that in your system prompt. For example, if I want the model to always answer in Hindi, then I'll put it in the system prompt, like always answer in Hindi, right? I'll apply this, and then I'll ask it, what is my name? If you see, आपका नाम शिवा है. Now you would say you could have written that over here in the prompt as well. He, what is my name? Answer in Hindi. I could have done that also. But if I set it in the system prompt in my chat application, I don't need to always ask it to do the same thing, right? I will still consume the same number of tokens. We are not doing anything which is optimizing anything over here. The only thing that we are doing is we are making sure that the role of this particular chatbot is set in the system prompt so that the user doesn't need to continuously keep telling what the model has to always follow. So that's the reason system prompts are important. If you want the model to always follow a certain instruction, you should always add that in the system prompt. If you don't have any such scenario, like usually people don't have, but if you are, let's say, something in an HR department, and you would always want the model or the chatbot to behave like an HR and whatever they are called, so you could say that, okay, uh, assume the role of an HR, and then you just apply and you ask, what is my name? Yeah. You see, your name is Shiva, you introduce yourself with the name, whatever. So it's talking like an HR, you know. So that's essentially what these things are. And these things are very important when you are actually building AI based applications, because you need to know what goes where. Then only the model behind the scenes will behave the way you want it to behave. Otherwise, it will just do things which you don't know why it is doing. And that's a very wrong or a bad place to be in, because then you are the one who needs to ultimately go and sit and talk to the clients and tell them what your application or what your product is doing. And you become answerable. So this, all these settings basically give you certain amount of control on what the model, which is completely a black box for you, is doing. And that is a bit powerful. Uh, I'll again take a pause over here. If any one of you has any questions, yeah, you can take them.
So I have just one thing. So the temperature that we are setting, like you set it at 2, right? So is it rebalancing the whole probability, or like it is like running some other logical thread behind to generate it? Because otherwise the probability as a match should remain the same, right? Like within the same data set.
That's a very good question. That's a very good question. I didn't want to go very deep into that, but you are very right. If it is only, where has it gone? Yeah. If it is only damping down the probabilities, that doesn't really mean that it is the max is changing. Even when I'm setting a temperature of 2, the max will still be for the only, right? I'll try to see if I can appearance zoom in control equal to oh damn, sorry. How to do how to go back and control that will it work? Okay, I messed this thing up. Hmm, नहीं किसी को बताया गया यार इसका शॉर्टकट क्या रहता है तो इन VS Code to unzoom. H,
You can press shift, I guess, control shift minus.
control shift minus. No, thank you. I was doing that only. I don't know why it didn't. Okay, anyways. The point being, yes, you're right. The maximum probability doesn't change. The maximum probability is still for the word the. And that's the reason only temperature is not the thing that will introduce randomness. There is something called as top P and top K. Now, the top P and top K, what they essentially do is basically they filter out, right? Now, top K keeps only the K highest probability tokens and zeros out everything else. Then renormalizes so that it again sums back to 1. Again, the max will remain the max and anything, the order of the tokens still remains the same. Top P also. Top P instead keeps the smallest set of tokens whose cumulative probability exceeds. Unlike top K, the number of candidate tokens adapts. These are some values that we set to basically, nullify or, damp down the probabilities. The actual way that the next tokens are chosen is an algorithm that runs behind the scenes. And that algorithm, there are multiple algorithms that run behind the scene. One of the algorithms is to literally take the top prediction always, right? Which is what we are running over here right now, right? It will always take the top prediction, the probability. In that case, you set whatever temperature you want, it doesn't really matter. It will just choose that. Then there are a bunch of other algorithms. I will just take you to those. For some reason, I just blanked out and I can't remember the names. But yeah, was the next difference in LLMs. Yeah. So if you see, there are multiple algorithms. One is called as greedy search. At each step, the algorithm chooses the token with the highest probability, what we were doing. This is mostly default many a times. But beam search is something that most of the models usually use, right? Instead of tracking only the single highest probability token, this method maintains a set number of most likely sequences. So what it does is it takes two or three from the top. So it will take the top three probably, and then it will predict for all the three. So like in our case, let's say the next best prediction was the over here. So it will not just take the, add it to the original sentence and predict the next word to the. What it will do is it will predict if I had taken the as the next word over here, right? What would have been the next to next word? If I had taken now as the next word, what would have been the next to next word? If would I would have taken a as the next word, what would have been the next to next word? Now the next to next word will also get some probability over here, right? It will take the cumulative probability of this, this, and this. And that might have different values because the ka to yahan pe the probability is large, but the next to next word might have a very low probability, right? And the cumulative probability for that might be lesser than something like this that might come with now, right? In that way, beam search basically what is done? Yeah, beam search takes different values. It continuously, explores these branches to find the most probable probable multi-token phrase overall, which is essentially what it does by, taking the cumulative probability and then choosing the sequence of word which gave the highest cumulative probability. That is what beam search does. I kind of dumbed it down a little. Beam search is a little more involved than that. Anyone who has learned algorithms will know better how beam search works, right? And then there are a bunch of other things, top K sampling, top P. So all of these we already know. Top K, top P we saw. Typical sampling, I don't even know what that means, right? But then there are a bunch of sampling methods, and that is the actual reason why ChatGPT gave different poems all the three times that I did, because the algorithm that it uses is different, and this algorithm makes it probabilistic and not deterministic, which essentially means every time it could actually choose something different because it is choosing based on probability. It is not choosing based on determining, exactly the top token always. Yeah, that's actually a very good question also.
Even like the chat context, like which we were using, like you made it for 20 chats, right? Even that would be used like in determining along with these
Yes,
searches, like beam
yes,
search.
yes, yes. That definitely that will also get determined because the longer your context is, the better the model predicts always, right? If you know if you know a person since last 10 years, you would know how they would behave in a certain situation probably tomorrow. So that's literally the analogy that even these models take, because the more the context it has, the better it is able to predict next. And uh, even though that is the case, these values that we are setting, the parameters that we are setting, make more difference than only the context. If you give it a very good context and you set a temperature of 2, it will still generate gibberish probably after few tokens, like we saw in that case, right? So that is still possible because we are doing model settings. If you remember the two kinds of settings, model settings play a lot of role in predicting the next token compared to the chat settings, because chat settings are peripheral things. Yeah. Cool. Any other questions? Anyone else? Okay. So I'll go to. So yeah, this is basically about it when you come to chat and the different kinds of things that you can do in any chat-based application. Now, let's say you come across a situation where you actually in your work or wherever, right? Usually, a lot of places you come across, situations where you need to build chatbots. These are all the things that you can do while you're building a chatbot. So next time someone says that I've built a chatbot, just think of it as this is what they have done. And yeah, that's about it. We already saw what a model library is. Model library is basically a place where all the models are listed. They have a leaderboard, they have a chart. You can go through them, you can understand what it does and everything. Prompt editor is something that usually these platforms provide for us to write prompts and save prompts. This is a very important feature. This has got nothing to do with generative AI. These are best practices in general, right? Whenever you write a code, you should always give it a good project name. You should always put it into a collection, which is essentially a project. So assume collection as a project. The project should always have a folder. Within that folder, you should have multiple codes with very self-explanatory names. So let's say if I say poem could be my project, Hindi poem could be my prompt. And over here, everything else is the same, whatever parameters we had seen earlier, right? So if you see max tokens, whatever max tokens you want to set, a temperature, I'll keep high. Okay, there was one thing called a streaming response. Now, streaming response is how you see the response on the chatbot. If I go back over here and I ask it to write an essay in 2000 words, you'll see that you can actually see everything streaming one after the other, one after the other, right? This is called a streaming response. For chat applications, it's very important that you have streaming responses because there is some parameter called as time to first token, which is called TTFL. TTF TTFT, time to first token, which means the user experience is like, okay, answer generate hona start ho gaya. The answer is already started generating, so I can start reading something. So they are not really blocked till the last token is generated, right? This is a very important thing from a user experience point of view. But there are certain cases where everything is running in the back end. So you don't really need to stream response, but you need to generate a output at once probably, right? If I'll just change the streaming response back to normal and I'll do the same thing. If you see, it is not streaming anything, but it is actually doing generating the next tokens in the backend. But till the end of text token is generated, which is when it knows that okay, I need to stop now, it will keep generating. And if you see, it has given the output at once, right? So this is something which is a streaming thing. It is more of a user experience kind of thing. A parameter that is used to judge a model is time to first token. How quickly can a model generate the first token? Because as soon as the first token is generated, it will start streaming the rest of the tokens also. So some parameters are like time to first token, TTFT, tokens per minute. How many tokens can it generate per minute? Tokens per second. How many tokens can it generate per second? Because all of these matter for user experience. If you want some chatbot where you want the user to see very fast outputs, you are fine if the accuracy is not very good. You should choose a model which has a very low TPS or TPM, because you are generating more tokens per second, which means the user will be able to see the answer very quickly. Whereas you see all of these thinking models, very large models, I showed you in the last session also, those models take a lot of time to generate tokens because they are very large models. So you shouldn't use those models in cases where you want to have, very quick responses. You should use them in cases where you want to do very deep research and things like that. These are things you should, generally know. And streaming is one way of unblocking the user from a user experience point of view. Then, yeah, we were in prompt editor. Prompt editor is essentially the same thing what we have done until now, but it saves your prompts, right? It versions your prompt, version controls your prompt. It puts it into a collection so that when you want to use the same prompt again later, you would know which was the prompt that worked best for you, right? These are all best practices in general. This has got nothing to do with generative AI in general, but these are best practices because we are talking about using these things in enterprise. We should know about all these things. Then prompt management again is very similar. You could create the same thing again, the same thing back to the whatever we were doing. And you can manage your prompts. You can delete your prompts, you can delete your collections and things like that. I will go back here actually. So what have we covered? We have covered chat. What the hell, man? Yeah. We have covered chat, we have covered prompt editor, we have covered prompt management also, which was essentially the same thing as prompt editor, but as you can see, these are collections, right? That you can create and use. Uh, prompt engineering is something that we have covered in a certain way in the last session. But if you see, prompt engineering is not a thing today because the models are so good that you have to be very bad at writing your prompts to get wrong answers, right? If you are even decently good enough in telling what you really want, whatever is in your mind, you are good enough in writing that on a paper, you are a good prompt engineer. So the things that matter in prompt engineering are not actually writing a very good prompt, but actually doing other things like selecting the right model for your use case, you know, understanding the use case properly. Because as you can see, if you want to do text classification, which is like spam, not spam, your email is a text body, right? So you take a text body, you classify it as spam and not spam. You should be very clear about that intent. You should write a good system prompt telling the model that you are an email classifier, your job is to classify an email based on the content, all those things. And then whatever email comes, that becomes the user input or the user prompt. The text of the email becomes the user prompt. Whatever you want the model to do becomes the system prompt, and you classify it. All this user prompt, system prompt, assistant prompts are just jargons to structure your prompt so that whenever you give your prompt to someone else, they should know what is happening. If you just write a haphazard prompt, which you understand probably works very well for you, but when you share it with someone for maintenance, they are not able to understand, then it's not a very good thing for an organization. So, as an organization, as someone who might be managing teams who are doing all of these things, you should always, ask these questions on how are we structuring our prompts and those things, and that is what prompt engineering counts for, right? And then there are two things which are uh, a little different from what I had actually intended. I don't know what this pre-trained transformer model is useful for, but this is like a model which can predict numbers, right? Uh, until now, we have seen all the cases where we were predicting either the next word or predicting, let's say, next audio token or whatever, right? But this is some special SAP model that they have created. This is completely created by SAP only, right? Where they are essentially predicting what we call as structured data. What I mean by that is, if I am a hotel, right, and I have made a revenue of some value per month in my last 5 years. So every month I have made $1,000, $1,020, $1,050, whatever, right? And I have that data for every month. If I give all of that data to this model, it will be able to predict in the future what will be my revenue, right? So this is a very dumbed down version of what this type of a model can do, but this is one of the things that this model can do. There are other things also, like it can, 128 simultaneous prediction rows, 10 simultaneous prediction columns. So a lot of structured and numeric data can be generated using this model. Like I told in the beginning when Yogendra asked, anything that can appear over a period of time can be predicted using these models. And this is a very good example. The revenue example that I gave for a hotel, you know what has been the revenue over the last 5 years, 10 years, whatever. You give all of that as a model, as an input to this model, and it will tell you what will be the revenue for the next 5 quarters or next 5 months or whatever. Right? So these are some, numeric generation models. I had actually worked on a project within my organization where we were doing literally this using transformer models. Uh, It failed miserably. Then we switched back to traditional machine learning models. But that doesn't mean that it fails always. For our use case, it wasn't relevant because we didn't have a lot of data. These models take a lot of data to do good predictions. If you see some examples over here, they have given inventory management, predicting stock levels, reorder quantities, product classification. So if you are working in some such use case where you need to do some inventory management, predicting what would happen in the future, what kind of stock piles you need to keep in the future, this is some model that you can actually use for that. Okay, we are already past 5. I'll take a pause over here and we will continue with the next these two parts tomorrow. But I'll take a pause and I'll wait for any questions that anyone has.
Shiva, are we going to continue on this SAP platform?
We will continue, we'll complete this. The intention was to take you through something which was enterprise level, but still easy for consumption, and gives you like a basic foundation of what are all the things that people are doing in, this. So if we go to this orchestration, right? Orchestration is literally putting all of these things together to build like a real use case, right? Over there, grounding comes in, templating, data masking, all of these things come in, which essentially is a, composition of a pipeline, which you usually build when you're building LLM or AI based applications. So yeah, uh, we'll continue on this. We'll complete this, and then the the plan that I have is to go to something like this. Claude Architect certification. If you see this, Anthropic themselves have created a kind of a roadmap for someone to learn this whole skill set, right? Which is because I know that many people are fairly experienced, like 8, 10, 12 years experienced on this group, right? And if if you want to use something in an enterprise, you should be enterprise ready, right? So you can't just go and say, I know ChatGPT, right? You should know more deeper things. And Anthropic is a front runner and at the forefront of this. So they have created something like this, which essentially has, you know, agentic architecture and orchestration, tool design, MCP integration, all of this. If you haven't heard about these things, then you might feel a little, overwhelmed. But one part of it is prompt engineering and structured output, which is what we will complete tomorrow over here. If you see in this also, you have something called as templating and grounding, which essentially is more or less like a part of this structured output. Context management is literally what we saw in the chat context setting that we saw, right? The chat context that we saw, that is literally context management, right? Reliability, we didn't touch upon reliability, but temperature is a very small part of reliability. How do you say that your model's outputs are very reliable? One way to control it is by setting a very low temperature so that it doesn't go crazy. It always predicts meaningful things, not really the same thing every time, because the algorithm matters more than the temperature. What is the search, the beam search or the greedy search? But temperature is one very small part of reliability. There are many other things that we can do in reliability. The ideal goal is to probably over the months actually cover all of these things. You might not be able to take this certification yourself because that needs like your company to be a partner with Anthropic and all of those things. But if you know even like 60-70% of this, probably today I know only 40-50% of whatever they are talking about over here, right? But us as a group, if we know even 60-70% of whatever they are talking about over here, you are probably in the top 1% of people who know how to build agents, how to use generative AI in their enterprise applications and whatnot. And yeah, that's the ultimate goal. Sorry for the very long answer, but that's it. Thanks a lot, guys. Have a good evening. Bye. And I'll post for tomorrow's this thing. We'll continue and complete this. And the larger goal is to, follow the path that this Anthropic this thing has. We will, of course, try to cover as much as possible, but uh, I always think from the point of view that it should be easier to understand, but not dumbed down so much that it becomes irrelevant. So I'll try to maintain that over the course. Yeah, great. Thanks a lot. Bye bye.
Thank you. Thank you.
Thanks a lot, guys. Have a good evening. Bye. And I'll post for tomorrow's this thing. We'll continue and complete this. And the larger goal is to, follow the path that this Anthropic this thing has. We will, of course, try to cover as much as possible, but uh, I always think from the point of view that it should be easier to understand, but not dumbed down so much that it becomes irrelevant. So I'll try to maintain that over the course. Yeah, great. Thanks a lot. Bye bye.
Thank you. Thank you.